Why do decision trees struggle with extrapolation and regression? Imagine trying to predict the height of a plant based on sunlight and water, but your model only knows about plants within a certain size range. Decision trees work well within the data they have seen, but they stumble when asked to predict outside that range. That's because they split data into chunks based on the training examples and assign a constant value to each chunk. When a new input falls outside these chunks, the model just guesses the closest known value. It cannot extend trends or patterns beyond what it has learned. Decision trees divide the feature space into regions by asking yes or no questions about the data. Each split narrows down the possible outcomes, and the final prediction is the average target value of the training samples in that region. If a new data point falls outside the range of the training data, the tree still assigns it to the nearest region, which is limited by the observed data. This means the prediction can never go beyond the minimum or maximum target values seen during training. Unlike models such as linear regression, which fit a continuous line or curve, decision trees do not create a mathematical function that extends beyond the data. Linear models can predict higher or lower values because they are based on an equation that continues infinitely in both directions. Decision trees, on the other hand, are like a staircase. They only have steps at the points where the data was split. Outside those steps, they cannot climb or descend further. This limitation is especially important in applications like forecasting or predicting future trends. If your data shows a rising pattern, a linear model can continue that trend, but a decision tree cannot. It will just stick to the range of data it has seen. This makes decision trees less suitable when you need to predict values outside the training data. Practitioners often combine decision trees with other models or choose different algorithms when extrapolation is necessary. For example, using linear regression or polynomial models can help when predicting beyond the observed data range. Updating models regularly with new data can also help extend the known range. Understanding this characteristic helps in choosing the right tool for the job. If you need to predict values beyond your training data, relying solely on decision trees might lead to misleading results. Being aware of these limits ensures your predictions are realistic and trustworthy. In the world of artificial intelligence and machine learning tools like ChatGPT, DALL-E, or Midjourney, knowing the strengths and weaknesses of models helps set proper expectations. When building productivity plugins or data analysis tools, selecting the right algorithms ensures accurate and reliable outputs, especially when dealing with data that might go beyond what the model has seen before.